Okay guys, welcome back to the second part of the video. So we were talking about something that we'll try to see here, which is actually causing this pattern, right? So we knew actually this is happening because we only gave input to sine waves to this simulation, uh, but what's actually happening in the backend, right? That's more important than this one. We know that we gave sine waves and this was generated as a pattern, but what is actually happening, how these patterns are, as I said, we had constructive and destructive interference, and how is that actually occurring? Okay, that's what we will try to delve here. So let's start. So for now we'll actually do something like this. So you see this, as I said, this is a point, right? And we had some distance from it, right? And we have circularly same distant points on the screen to each of the sources, right? So in each of the sources individually, each point of the line will be having same intensity of light due to that particular source. Okay, we're not talking about interference currently, not talking about superposition currently. We, if we had only one source, so we can think of that light is kind of getting emitted spherically, and because this is 2D, it's circular, right? So we'll try to draw circles. We'll try to draw circles here, and same distance circles. Okay, so circles with the distance of 0.2. So each of the circles will be having a 0.2 distance from the previous one, and each of the circle will be having some radius. The radius will be length space again, and that's x min to x max, right? So this is the difference, the distance between two circles, two concentric circles, and we can divide our screen, our x-axis, into some radius, right? So as I do it, it will be more clear. So it's x mean minus, so it's x max actually, x mean divided by interval int, okay, radius. Now you see, okay, we have a problem here, I guess. Yes, we do. Yeah, now you see, we need to increase this. uh, so we have 10 points here, 1 2 3 4 5 6 7 8 9 10, and they're kind of equidistant to each other, uh, and these are basically the radius of each of the circles, right? You can think of 10 circles with this radius. The 0 is just a point circle, and then we have these circles which are the same radius. So we'll have to draw this radius circle. So we have to draw 20 circles actually, 10 for the first source and 10 for the second source, right? I hope it's clear. So we have our source 1 and source 2, as you remember. Now what we need is basically uh, we need to import now for better. Yeah, we need to use dark background for better visualization. Okay, and we need to have different colors for these two circles so that we can understand what is actually happening, where we are having the different phase and where we are having the same phase, to understand the interferences where they're constructive and where they're destructive, right? So yeah, that's all. And now we need to limit our axis as before, so we'll have something similar to this one. Sure. Okay, and then we need to have figure comma x equals to pat dot subplots fixed size equals to 10 comma 10, right? Now we need to draw the two circles. Okay, but again it's going to be 10 circles for each of the sources. That's why we need a list actually here. We'll also try to keep it a small one, a small figure, so that we can have better understanding. You'll be able to understand it after I have actually done it. For now we just need to keep it smaller, so that the things are dense, right? Now we need to create two circles, like two list of circles. The first one is for source 1 and the second one is for source 2. Now for radii in radius, so radius is a list of all the radius, right? So we are trying to have to look through each of them. Now cs1 will be so okay, we need to have circle first, that's circle 1 plot dot circle the center, right, radius, and the okay, the face color. So we have two colors here. The internal color, we need to make it transparent, otherwise it would overlap with each other and will block the other one. So face color should be anything but transparent, right? Then we have edge color, which is equal to red for now, right? And the other one will be green actually, but okay. So we need to add this circle to our list dot append circle 1, right? And we need to do the same thing for the second source as well. This is circle 2 and this is source 2, but this one is green, okay, yellow, okay. Also we need to show those 2 points, so we'll just scatter them here, those 2 points, right? So let's make them white, okay, because we are going to use a dark background, it might look cool. I'm just trying out random color choices here. Okay, that's it, I guess. Now we need to update it, okay. So for I in range 10, right? Okay, for now we just yeah, for I in range 10 we need to, so what we'll do is basically our circles will be traveling, right, because light travels and we'll be having some velocity for that. So our velocity will be something less than interval works. I'm going to do it 0 to 0.002. So what will happen is basically cs dot, so cs I think it should be c for I comma enumerate cn enumerate cs cs1. uh, yeah, so what will happen is basically we are going to set the values again, right? Set the radius of the circle, because traveling circle means just that it's increasing its radius, right? So the radius is going to be modified as radius I, and same goes for this one as well. I think we have done correctly. Yeah, sure. Now, at the first look, at the first pass of the loop, these two are basically doing the same stuff. Whatever radius we had, it's going to put them the same, right? Because it's just 0, and so we have the same thing we are doing again and again. But okay, we have done something wrong here. We need to ax dot add subplot, I guess. I forgot the method. I guess it is add artist. Yeah. Okay. Now, okay, this should be CS2 as well. Now, after the first pass, so we are having 10 passes for now, just because we are in the coding phase. We'll increase it later. So radius, so each element of the radius will be increased by radius plus velocity, because velocity means it's traveling, and traveling means the circles are getting bigger, right? So that's what we need to do. But uh, there is a small trick that we need to do here. Percentage x max minus x mean. So this would help us. So what will happen basically is that we have a very limited region and we need to reproduce the slides. Okay, so if the radius gets bigger and bigger, we have x-axis of 10 length, and if we keep on adding velocity with radius, sometimes it might go out of 10, right? So whenever we have something more than 10, it will get back to circularly, it will get back to our starting point again, so, initially, and would it kind of helps us regenerate our waves in the same frame. Okay, this is just for our plot purpose, because if we don't do this, after few time the wave would get bigger and bigger and would vanish, disappear, right? So that's what we need to do here. And a small trick that we need to do here, because we are using ipython here, ipython Jupyter Collab, I'm sorry, ipython Collab notebook. These are the things that you need to do when you are updating the plot, right? So let's see if it's working or not. Maybe some problem. Yeah, access a plot doesn't have this. I think it's add artist or artist. Okay, it's doing something. Hmm. Okay, this was x lim and y lim, which is understood. uh, then we have okay, these are the, this is not needed, but this one is important. So it says we have 2 circles, something wrong is going on. Okay, let's try to the sources again. So 0, we have okay, we need to have xlim, something has gone wrong here, because we need to have, okay, let's do it here, maybe that might help. Okay, so it's working. I'll show you what's so what happened basically is that we created the plot instance, but before creating that instance we were doing some limit function for the default plot. Okay, right, so we have this plt which is a kind of works for default plot, but we created our own instance and then we should update it, right? So that's what happened basically. Now we will go for visualization, right? So hit it. Now you see it's actually increasing, which is kind of cool. So these are the two light sources, and what I want to show you basically is that why that is happening, right? So okay, let's try to decrease the interval a bit, which might help in explaining the stuff of uh, interrupting, then hitting the button. Okay, now see, this is kind of the same as we had there. The only difference is that the blank part represents a high intense region in the screen, right? In this screen, one more trick we need to do is that basically is that here the waves are disappearing, so we need to limit this to -1 only. We'll just do that. Now what is happening is that well, also we can do 7. Okay, interrupting execution, and we'll run it again. Cool. Now see, this one is almost same as this one. Now I'll say what represents what. See, the red one is for circle 1, like source 1, and the yellow one is for source 2. Now what is happening is that you see when they're intersecting each other, right? That means they're kind of in the same phase, right? So it means that when they're in the same phase, it will be a constructive interference, right? So you see here in the center of the screen we are expecting a high intense region, right? So that is what we will actually have here, because these two circles are constructively interfering with each other, right? Similarly it goes for this part also. Okay, so when where we have this black strips, like empty strips, those are actually representing constructive interference, and that's why they are uh, intense regions, right? But when you see, okay, I'll just interrupt the execution. Now you see we have this focus on this intense region and this intense region. Now between two intense region we have these points, right, where actually these two, so here and here, you see here at this point and this point these two waves are in phase, but in between somewhere they're out of phase. That's why they are actually not uh, intersecting each other, right? They're not intersecting each other, and that means we have a destructive interference there. So along this line actually, see where we have a sparse region, a lot of lines, those lines are actually indicating that we have a destructive interference there, and that's why we'll be having something like a emptiness there, right? Because they are intersecting with each other and they're destructively interfering with each other and cancelling each other, right? So that's what is actually happening. I'll just run it once more because it really looks cool. So that's how it works actually. uh, if you guys have any kind of question, I welcome you guys to put it in the comment section. Um and if you guys have any kind of suggestion or like recommendation for upcoming videos, I'm kind of a physics enthusiast, so you can expect some more videos on similar topics. Maybe something can come up also relating to ML. But yeah, that's all for today. Thank you guys.